Okay, so they want us to get the loop current using mesh analysis. So the first thing I want you to know is that we're going to be using KVL. KVL basically says the sum of current rises, so something like a battery, plus the current plus the voltage drop, which is like across a resistor. Add all of them up and equate them to zero. That's simply it. I'm going to be representing voltages in this case as V equals IR, Ohm's law. So now our mesh loops are going to be 1, 2, and 3. So this is going to be I1, it's going to be I2, it's going to be I3. The only thing complicated about this question is just it looks congested, that's all. So first I'm going to start it. So it's going to go like the current is going to go like this for this particular one in this direction. So first it's going to come here, as it's coming like this now. Is a drop across, voltage will drop across it. So here will be plus, here will be minus. It's going to be for mesh one, it's going to be plus 7 as the resistance. Then the current is in this case is I1. Then when we come here, what's the first this thing you see here? It's positive. Some people like to use the one after. You can do it, but I don't like that. Plus 16 volts. Then across this resistor, it's going to drop. But notice how this resistor is in between mesh 1 and loop current 2. So it's going to be plus 4 I1 minus I2. And the reason why it's I1 minus I2 is because we're currently in mesh 1, so it's I1 minus I2. If you're in mesh 2, it will be I2 minus I1. The next is this particular one, current drops across it. It's going to be plus, it's in between I1 and I3. So plus 4 ohms, I1 minus I3 equals to 0. Simplify it, you get 15 I1 minus 4 I2 minus 4 I3 equals to 16 minus 16. First equation. For your mesh loop 2, let me erase this so that we can clearly see what I'm doing here. So for the mesh loop 2, you're going to be going in this direction. I always just like to draw my current like this by default. So starting here, current will drop across, so it will be 4. But this current is in between I2 and I1. In this case, it will be I2 minus I1. I already explained why. When you come here, the first sign you're seeing there is what's minus 16. Then plus, this is current to drop across. Sorry, voltage drop across plus 4 times I2 plus current drops across, but this is in between what I2 and I3. So this will be 3 I2 minus I3 because we're in mesh loop current 2. Then this particular one, this is the positive sign first, so it will be plus what 12 volts equals to 0. Simplify this, you're just going to get minus 4 I1 plus 11 I2 minus 3 I3 equals to 4. Then for your loop 3, as your mesh loop 3, it's going to simply be, let me erase this so we can see clearly. It's going to go like this. So when we start from here, we're going to have minus 12 volts, right? Plus, in this case, this is 3 ohms is trapped in between I3 and I2. So it's going to be 3 I3 minus I2. You know what is I3 first. Plus, in this case, this 10 is just on its own. So it's 10 I3. Then this is going to be plus 15 because the first symbol I see there is plus. And then 4 is going to be plus 4 because voltage rate drops across, but it's caught in between I3 and I1. So I3 minus I1. As simple as that equals to 0. If you simplify this, you can get minus 4 I1 minus 3 I2 plus 17 I3 equals to minus 3. This is your third equation. This is a simultaneous equation. I feel like we can all solve them. If you solve it, you can get that I1 is equals to minus 1.268 amps. I2 is equals to minus 0.238 amps. And I3 is equals to minus 0.517 amps. This is your final answer. Thank you for listening.